the first problem was about that shape factor. So all those table and chart is to calculate that shape factor. It's the fraction of how much the radiation leaving surface A will hit surface 2 or 3 or 4 or 5, depending on how much he see. That's how much that surface represent out of the sky around him or the dome around him, right? So that's why we care about that shape factor. And so the tables are there for normal surfaces, the table are there for, say, parallel surface, but some combination that may be practical are not on the table, and that's why we need all those summation rule, reciprocal rule, all those rules is basically to make up for what we cannot find in the table. So for example, in that homework, here is surface 1, and here is surface 2, and required is F12. How much of the radiation leaving surface 1 will end up hitting surface 2? And he gave us the geometry. So this is 1, 1, 1, 1, and the width is basically 4. Right? So again, if I look at the table or the charts I have, we have this configuration, right? Which table is that?
Table 13, figure 13.
Figure 13.
Well, that's the graph.
Okay, 13.
Table 13.1 is the table.
Right, and the graph is figure 13.6, right? All right, so you wish basically that 1 would have been the whole thing over here, but it's not, right? 1 is only the guy on the top. So because of this, you should think about, well, what if I get the whole surface on the top, everything, to 2, and then split that, right? So that's how you should think about this problem. So basically, you'd say, let's, here in that solution, you call this 3. And so now 1 and 3, we could think of this as basically one surface. And basically, you would say, well, F2 to that new combined surface that's called 1 plus 3 is basically the summation of F to 1 plus F 2 to 3, right? The radiation going from 2 to that new big surface 1 and 3 is basically 2 part. Part going to 1, part going to 3. What he's asking about is, he's not asking for F21, he's asking for F12, but there is a relation between F12 and F21, right? If I know one of them, I can get the other. What is the relation between F12 and F21? What is the relation between F12 and F21? It's called the reciprocal rule. F12, area 1, is equal to? Very good. Well, whatever, whether the area are the same or not, but the point is that if you know F12, you can get F21, right? From that reciprocal rule, right? So this is what's really required to calculate, or its counterpart. And so I need to get this, and I need to get that. Fortunately, table exists for this, and table exists for this. See, from 2 to 3, that's exactly our table. 2 to 3. 2 surfaces normal to each other, and 2 to the 1, 3, 1 and 3 is also there. All right. So all I do is basically just let's work on getting those two guys. So the table basically require L2 over W and L1 over W, and you have to basically it's 1 over 4 and 1 over 4, and from that you basically will be able to say that, well, F2 to 3 is 0.26. So out of all the radiation leaving surface 2, surface 3 will get 26% out of it. Okay? And the same thing for F2 to 1 and 3. So for that, basically the geometry would be L2, and I'm saying L2 and L1 based on that figure. So that's 2 over 4 and L1 over W. Those are the two surfaces that are basically normal to each other, is 1 over 4. And so from that you will get F2 to that new surface that's called 1 plus 3 is 0.33. Right, so it turned out that this is 0.33 and this is 0.26. So 33 is 0.26 plus this guy. So it must be that F2 to 1 is the difference between them, which is 0.07. This also happened to be the same as F1 to 2 because, as Bob said, area 1 and area 2 are the same. Alright? So it's 0.07. Question about this?